Hey guys, welcome to Coding Science. Today we'll take a look at the concept of a stack. That means we're not bothering about the details, we'll just focus on how it works. So let's get started. Okay, so let's start. And what is a stack? We'll go through the concept, but first a small definition. A stack is a container of objects following the last in first out principle, also called LIFO. It is possible to insert objects at any time, but only the latest inserted can be retrieved at any time. So what does that mean exactly? I mean, short enough, but let's take a look at it with some visualization. So we have here a box. I'll show you here. We have a box that will represent our stack, and we get some objects that we'll put in and retrieve. We'll collect our actions here so we can remember what we've done. And here we will make a sequence of the result when we retrieve things from the stack. We'll start with filling up the stack and then emptying it completely, just to see the main idea how it works. And then we'll see another example. So let's start. We start by pushing some elements, 5 elements actually. The first element is 1, and the latest element is -2. It's the last element that we put in. So now let's pop them out and see who comes out first. So we're going to do the pop function, which is the word used for retrieving elements, and push is the word used for putting things in the stack. And as you can see here, the first element that came out is -2. It was the last element we put in the stack, and it became the first one coming out. Then it went to 5, 7, 3, and 1. So simple enough. So that was an example of filling it and then emptying it. But what happens if you wish to, let's say, push some elements and then pop some, and then push again, and then pop again, and so forth? Most programs will do something like that. So let's see how it behaves then. So we start from fresh, and let's push some elements. We push 1 and 7. Okay, so the latest element here is 7. So now let's pop an element. 7 comes out. Now let's push some more elements. 3, 12, and 5. Let's pop some. That 5 comes out again first because it was the latest inserted, and then 12. That was just before 5. Now let's insert the rest, or push the rest. There we go, the stack is full again, and now let's empty it. There we go. So as you can see here, we got a sequence starting with 7, because it was the last element inserted at the moment of the pop. Then we inserted 3, 12, and 5. And at that time, the last element inserted was 5. So when we popped, we got 5. So 7 and 5. Then it was 12 because we popped again. So we have a 12 here. So 7, 5, and 12, and so forth. It's not complicated, but it's important to remember, because when you're using stacks, that's something to take in account. Depending on the timing of your pushing and popping, you'll get different sequences. Well, that's it for the concept. If you're interested to learn more about the stack, I also published some videos on the data structure around the stack, and a video about how to implement the methods with pseudocode. There is also the full course that includes all 3 videos altogether if you wish to learn all there is on the stack. Thank you so much and see you next time.